All right, so we are taking a look at the team round of the 2013 competition, and we're taking a look at number one. Number one is actually an interesting logic question that does show up, something like it shows up on what's the LSAT, which is a test that aspiring lawyers take to get into law school. It says that the shirts worn by Rachel, Wendy, and Belle are red, white, and blue. Not necessarily in that order. For each girl, her name and her shirt color begin with different letters. Wendy is taller than the girl wearing blue. Who is wearing the white shirt? All right, so let's break this down. It says that the girls are not wearing shirts that start with the same letter as their first name. So that we know that Rachel is not wearing red, Wendy is not wearing white, and Belle is not wearing blue. Then it goes on to say that Wendy is taller than the girl who is wearing blue. And of course you're thinking, who cares if she's taller? I only care about who's wearing what shirt. But if Wendy is taller than the girl wearing blue, that means Wendy is not wearing blue. So right now, I have an extra thing filled in, I'm sorry. So here is the girls not wearing their own color. So Wendy is not wearing blue. Well, if Wendy is not wearing blue, because Wendy is taller than the girl wearing blue, that means Wendy is wearing red. Well, so we know that Belle is not wearing red, and she's not wearing blue, so she must be wearing white. And then, obviously, Rachel is wearing blue. But we only care about the white shirt. Who's wearing the white shirt? Belle is. All right. So then the next question. Oh, this is a very common mathematics question. Thank you, gentlemen. In the magic square shown, the three numbers in each row, in each column, and in each, I should start on 12. Consecutive odd whole numbers differ by 2. Examples are 5, 7, 9, 11, or 67, 69, 62, 71. What is the smallest of the three consecutive odd whole numbers whose sum is 45? Well, you can obviously guess and check, and that's going to kind of be a royal pain. I'm going to show you the way that I would do it, and then I'm going to show you a slightly different way. So the first thing I would do is I would say, okay, my first odd number, my smallest, is x. That makes my second number x plus 2. And that's kind of why they went to great lengths to explain that to you. So then my third number is going to be x plus, hopefully my board works at some point, x plus 4. Well, and then they're going on to say that the sum is 45. So that means this number plus this number is going to equal 45. Oh, okay. Well, I have x plus x plus x. How many x's am I adding together? I'm adding 3 x's. So we have 3x. 2 plus 2 is plus 4 is going to be equal to 45. And so then, oh geez, that's 6, my goodness. 6, because 2 plus 4 is 6. So then, that means this 3x plus 6 is equal to 45. Well, that means that this 3x has to be equal to 6 less than 45. So I'm going to subtract 6 from both sides. So I get 3x, both sides of the equal sign. So I get 3x is equal to 39. So x has to equal 13. Now another way that I'd be very, very tempted to do this, and let's see if it works out. I don't know if it is. But I'd be tempted to say, okay, so we have 45. If I'm going to divide this by 3, I'm going to find the average. So I divide these by 3, and I get 15. So that means the middle number is 15, So that means I would go 13 and 17, and then I could add those together. And obviously, 13 is it. This is what I would expect middle schoolers to do, but I think this is probably more common in elementary school. All right, for number 13. In the magic square drawn below, right here, the three numbers in each row, in each column, and each diagonal are the same sum. Well, I'm going to shut my door. Can you shut the door? So the rows, columns, and diagonals all have the same sum. What number belongs to the x? All right, now this is kind of a tricky problem because you don't really see any connection anywhere, and we don't know what the sum is. So, but we know that the sums for all of the diagonals, rows, and columns are all equal. So we need to find rows, columns, or diagonals that have two of the three numbers filled in. And the reason behind that is we know that they're going to be equal, and then we can sort of disregard the number that we don't know. And I'll show you what that means. So we have 2 out of 3 here, and we have 2 out of 3 here. So what I'm going to do is I'm going to say that we have, in the red, we have x plus the center number. I don't know what the center number is, plus 1. And I don't know what the sum is either, which is kind of a pain, but we're just going to go with it. We know that the red diagonal is going to be 22. I'll rewrite it so it looks more legible. 22 plus my center plus, I think that's 4. Yeah, that's 4. Plus 4. And it says that diagonals, columns, and rows are all equal to each other. So I know that 22 plus c plus 4 is equal to x plus c plus 1. Well, wait a second. This side has a c. This side has a c. They kind of cancel out, don't they? So that means I know that 22 plus 4 is going to be equal to x plus 1. Well, 22 plus 4 is 26, is equal to x plus 1. Well, what does x have to be? That's right, x has to equal 22. Or sorry, 25. And so there we go.